Okay. All right. Day 2, 3.1 notes. In example 4, we're actually not going to do the graph because we did letter A, 4 to the x. What I want to get us to see is the transformation. If you look at letter B, g of x is 4 to the x plus 2. How does this graph shift? Left, right, up, or down? Tyler?
Left 2.
It's going to go left 2. And I'm going to help you out on your quiz. It asks you to graph one of these, and then it says, make a table that indicates you understand the transformation. Typically, you would start parent function graphs from -2 to 2. However, since the graph has been shifted left, I don't want to start at -2. Where would I start? Excellent. It would start -4. That would demonstrate an understanding of the shift. Okay? Then in letter C, h of x equals 4 to the x plus 2 and a -3. So Adam, how does this one shift? How does this one shift?
Oh, left 2, down 3.
Good job. Left 2, down 3. We're not going to graph it. I know you can. Now, I want to make a more abstract connection. If f of x is 4 to the x, then g of x is really equivalent to f of x plus 2. Do you understand that? That if I went to f of x and I did f of x plus 2, that produces g of x. And then h of x is really f of x plus 2 minus 3. Okay? That's just an abstract way to do that. All right, now we're going to shift gears and look at e. Remember, e is irrational. It's like pi 2.7182818. It's called the exponential function. So what I want you to do is I want you to find your graphing calculators. And we're going to fill in this table, and we're going to use the ask feature. So something very, very fascinating happens here. You did?
I did, because I was...
You were bored or something?
Yeah, I was doing the homework. And then,
Oh, cool.
He was just having sort of weird, twisted limit asymptote thing. Can't get higher than continuous growth.
Cool. I'm having trouble with my pen.
Symbols.
I did too.
I was confused. 1 plus 1
Are you
divided
calibrated?
by x.
It's probably the bad pen.
Both hands
Okay.
are messing up.
Yeah.
Calibrate.
Okay, you guys ready? Now we're going to go to the ask feature. So do second window and turn that on ask because we only want these particular values. Let's plug in 1, 2, or not 2, kidding. 10, just kidding. 100, 1,000, 10,000, and 100,000. And something very, very interesting is happening. 1 plus 1 over x to the x power is producing what number? What's it called? Just defined it for you. E, right? Don't you see that? 2.718. Now, if you move on top of it, your table can only go so many places, but if you get on top of the y value, it really is, in some situations, going further out. Do you see how many places it went? So this is actually approaching E. Okay, so in your table you can fill in your numbers there, but this is actually a little bit of calculus. E to the x is actually equal to the limit as x approaches infinity of 1 plus 1 over x to the x power. In calculus we're going to talk about limits. And a limit is a very, very simple concept. It's the intended height of the function. So as we let x get larger and larger, that's what the limit as x approaches infinity means, it's going to produce the number e. Okay, so just planting some seeds right now for the future. In example 6, use a calculator to evaluate each expression. Let's go 3 decimals and see that you know how to use the buttons on your calculator. So do e to the negative 2. Okay, so just check them up here. Now, before we go to example 7, you have some extra space there to the right. What I want us to do is a little bit of review from last year. If you wanted to graph the parent function, y equals e to the x, you're going to need your calculators again. Any graphing with e will be on a calculator part. Now the goofy thing is your quiz is take home, so of course you're going to use your calculator on all of it if you so desire. But let's go ahead and pop this one into our calculators. Okay, so at negative 2, I'm getting 0.14 if I'm rounding. Negative 1 is 0.37. At 0 is 1, 2.72. And then 7.39. So let's make a little sketch here. And this should make sense based on what we did yesterday. This is an exponential graph and its growth because e is like 2.718. Your domain is all real numbers. The range is y greater than 0. And there's a horizontal asymptote at y equals 0. So this should be review. Now what I want you to do is example 7. I'm going to give you a head start, and I want you to do this on 2 different grids, not on the same grid. For A, make an XY table, negative 2 to 2, and on B, do a table negative 2 to 2, and graph that. It is assumed when you're graphing that you identify domain, range, intercepts, asymptotes. Okay, so make sure when you're doing that on your homework or on your quiz that you're doing that. And like each of these, since there's not a shift up or down, there's no x-intercept. Okay, it's not going to cross the x-axis. as you're approaching finishing that second graph, something I want to take a moment and get you to look at and think about. And this was really the point. In letter A, you should have had a growth curve. Now it was a little bit slow because it was a 0.24 in front of the x. And in B, don't you have a decay? Well, here's the generalization. And I want to make this awesome connection to what we've been doing. If you think about this, if I have y equals, and it's a positive number times e to a positive x, there's your general, and it's a growth. But watch what happens. If I replace just the x with negative x, what kind of symmetry is that? When you replace x with negative x. Y-axis symmetry. Good job, okay? So now, this is y-axis symmetry. Did you guys notice? This stuff isn't going away. It keeps coming back to us. And look at it. It really is a reflection over the y-axis. And then, now if you go from the top left to the bottom right, do you see that that's a y equals e to the x, but I put a negative out front? What kind of symmetry do I have when you put a negative out front? X-axis symmetry. So then I've got some x-axis symmetry. Well, not symmetry, but a reflection there. So look, do you notice that? It just flipped it, but now it's a decay. And then if I take this one, I take my y equals e to the negative x and I stick a negative out front, it does y-axis. So, okay, what's my point? My point is this. Next year, if you do AP Calculus, or even if you do regular calculus in college, there is an expectation that without even having a calculator, they could give you one of these functions and not expect you to do a formal graph, but to have some idea. They're going to talk to you about limits and say, okay, what's the limit of g of x in letter B? Well, I don't have a calculator. I need to understand that it's a decay. If I'm going to infinity, that's going to 0. The intended height is going to go reach 0. So you have to know that without even using a calculator. Okay? So just having that general understanding is important. All right, recall. Now we're going to shift gears a little bit more. Remember, if you are compounding money, you use A equals P times the quantity 1 plus R over N to the NT power. If it's compounding continuously, you're going to use PERT. Alright, so I know a lot of you have a program for both of these. Let me tell you my minimum expectation. Here's the minimum. You need to indicate to me you knew which formula to use and you plugged in the numbers correctly. So in this one, I'm going to put, I'm investing $5,000, 6%, compounded annually for 10 years. This is the absolute minimum. Then use your program if you'd like. If you're sitting there thinking, how do some of these people have a program? Well, some either did the ACT workshop with me, or some people have written programs themselves.
Anybody in that class have this program?
I can make it for you.
And they would like to share it.
It's not that hard.
And you guys know you have those cables, right? You just link them. And I have been surprised in years past, my students have, like, then there's usually 1 or 2 really strong programmers who are writing the programs, and then they just start linking them, and then everybody gets them. I have not been seeing that going on. I've had a lot of students who don't know how to use their link. So, and I've tried to show you when I give them to you, I'm trying to say, okay, arrow to receive, press enter, so it says waiting. I'm trying to teach you how to do it. All right, try the other 4 using the appropriate formula. But give me this minimum, okay? Give me the minimum of what formula you're plugging into and plug the numbers in the right way. Interest, you change it to a decimal. Remember, move the decimal 2 places to the left, so 6% is 0.06. Is this out of order on your note sheet? Like, is your B daily?
B is quarterly.
Okay, so just kind of match them up. I think when I was trying to make my PowerPoint for this, I mixed them up. So just make sure your daily, monthly, quarterly are matching. Also, if you have an older calculator, if you have the TI-83, be careful. Once you hit your exponent, your caret, you have to put 365 times 10 in a parenthesis. Otherwise, you're going to get the wrong answers. And I would hate to see that on a quiz or a test by something that small. Bless you. Alright, check all 5 up here. Again, I don't know that my letters all match to your handout, but your daily, monthly, quarterly, continuously. But give me that one line before your answer, okay? And then you're welcome to use the program. Is this coming back to you? You guys remember how to do this? Okay. Any questions on compounding interest? Alright, then let's move on to the last example. Example 9 says, in 1986, a nuclear reactor accident occurred in Chernobyl in what was then the Soviet Union. The explosion spread highly toxic radioactive chemicals such as plutonium over hundreds of square miles, and the government evacuated the city and the surrounding area. To see why the city is now uninhabited, consider the model P equals 10e to the negative 0.00002845 t power. This model represents the amount of plutonium that remains from an initial amount of 10 pounds after t years. Now, that means 1986 is 0, okay? T is not 1986, because then that wouldn't work, would it? If I have P equals 10e to the negative 0.00002845 t power, the only way to get the initial amount to be 10 pounds is t would have to be 0. E to the 0 is 1, okay? So they didn't come out and say this, but I have enough information to conclude t is the number of years since 1986. It says sketch the graph of this function over the interval from t equals 0 to t equals 100,000. Let's pause for a moment before we attempt the graph. What does t T equal 100,000 mean?
Years.
It's 100,000 years after 1986. Do you understand that? We're talking, that's a huge amount of time. So let's go to our graphing calculators. Let's go to our y screen and let's put this function in. 10e to the negative 0.00002845, and we'll make it x power. Alright, now they want us to graph it from t equals 0 to t equals 100,000. So we're going to make it 0 to 100,000. Well, we don't want to go by ones. That would be really crazy. So let's go by, let's say, maybe 5,000. That's not the only way to go. Now let's think about the y values a moment. What was the initial amount they gave us? 10 pounds. And then what's going to happen over time? It's going to deteriorate over time and go down to, it can't go lower than 0, right? So let's put y min is 0, and let's try 10. We'll start there, and we'll go by ones. All right, this is a nice looking graph.
Beautiful.
All right, now I'm going to be let's then look at our graph here a moment. And because I don't want to make a whole bunch of tick marks, I'm going to be a little bit lazy here. And I'm going to make 2 tick marks on the x-axis, or my t-axis for time. I'm going to say 50,000 and 100,000. And we can be equally lazy on the y. It starts at 10, right? The initial value. So there's no arrow going left. You can't have negative time. And then watch what we can do. Let's press trace and do 50,000. And it tells me that the y value is about 2.4. So we'll plot that. And then let's do 100,000. And that's 0.58. That's really small. So we're going to graph this piece. And do you notice that I have dots on either end because it said sketch the graph of this function from t is 0 to t is 100,000. So I'm not continuing it on because I only wanted it from a closed, what we call a closed interval. All right, so now it asks us the question, how much of the 10 pounds will remain in the year 2002? Well, what do you need to figure out in order to do that? How much time has passed? So how many years has passed from 1986 to 2002? 16 years, okay? So enter that in your calculator then, 10e to the negative 0.00002845 times 16. Make sure the exponent, if you have an older calculator, is in a parenthesis. Otherwise you're going to get the wrong answer. Are you getting 9.995? Okay, guess that in 16 years, from 10 pounds to 9.995, do you understand why it could not be inhabited? And even after 50,000 years, we got 2.4. That's still, people cannot be around radioactive materials. All right, it says how much of the 10 pounds will remain after 100,000 years. We had already done that for our graph, didn't we? And it was 0.58 pounds.